Hello everybody, how's it going today? My name is Connor, welcome back to another video. Today we're going to be talking once again about my game engine I've been running a Rust called Weaver. It's been a while since I've talked about this project, it's been a few months. And the reason for that is that I just kind of got burnt out of the project. I was working out really hard for a really long time. And, you know, if you're watching my videos for a while, you kind of know that I just have this tendency to work on things, and then burn out of them. So that's kind of what happened there. But once again, the entire game engine has basically been scrapped and rewritten from scratch. Just kind of a product of my way of designing things, very iterative, very kind of try something, see how it works, and then try something else, see how that works, and then pick what works best out of all the things that I try. But you can see it's coming along. We have a texture cubes in here that with some materials that are metally, same metal material as before, just kind of scaled down a bunch, a little bit more realistic. Got these red cubes on top of the black floor here, so that's pretty cool. You got the color lights, so you cannot see where the lights are, but you can see the reflections on things. So yeah, pretty neat. Um, so talk about how the engine has changed. First things first is I have completely redesigned the entire architecture of the entire thing. In fact, let me close these assets. I've separated the engine into a bunch of mini crates, very similar to how a lot of other game engines and Rust do that. Each of these little crates kind of has their own little function of adding something into what the engine can do. So it all kind of comes together with this Weaver app crate, which has a plugin system, and this is literally all a plugin has. Is it has a name, so I can list them in debug information. I can build a plugin on an app, and I can finish building a plugin on an app. It's kind of like a two-stage thing where a plugin can set up any initialization that it has to do when the app is first being created, and then before the app starts running, it'll finish on all the plugins that have been added, and it'll kind of finalize everything that the plugins need to do. So, and then every single functionality that needs to be added to the base application, including anything related to adding ECS resources, more plugins or adding automatic systems that are just added via plugins. That all happens in the form of plugins. So it's kind of a elegant solution, I think, to allowing modular functionality to be added into the game engine. So, like I said, most of the engine has been scrapped already. And that includes the ECS. Fabricate, from my last video about this game engine, is no more. It's been completely replaced once again by a new custom written ECS. Entities are not too dissimilar from how they were before. There's only one type of entity now. There's no distinction between different entities that represent a type information or entities that represent blah blah or whatever. It's all just entities. Just an entity is an entity, doesn't matter, and they can be they can have identifiers and generations and stuff, and all the usual things that you expect from an entity in a system like this, a design like this. You also have relationships between entities, which I'm not currently utilizing this as probably as much as I could, but it's there. And then I also have scenes, and the scenes, and by extension the scene nodes, are a way of representing hierarchies and relationships in the ECS world. And scenes are self-contained, and they can contain other scenes as well. In fact, the nodes in these scenes can also just be entities that represent other scenes. So it's pretty elegant like that. And then storage is probably the most complicated part of this, as per usual for an ECS. We have about 700 lines of storage code representing archetypes and columns of archetypes and sparse sets, stuff like that. I'm going to go over all of this. It's just a lot. But this is actually pretty similar to how Fabricate worked. It's not a true ECS in that the iteration doesn't happen over the dense indices or densely packed vectors of the sparse sets. The reason I wanted to replace Fabricate is because it was just trying to do too many things at once. It was trying to do an ECS, it was trying to do scene hierarchies, it was trying to do reflection, it was trying to do scripting, etc., etc. And and as a result, I've also gotten rid of Loom. Loom is dead language now. It's not going to be worked on anymore. I decided if I am going to do scripting with Weaver, I'm probably going to do it with just Lua or something. So we also have this Weaver asset crate, and it's just a really simple system where I have this concept of assets and handles. So an asset can be loaded from somewhere and put into an assets resource, which is just a regular old resource that you can just add into an ACS world. And to add the assets as components to as a component to an entity, you now just add these handles into this assets resource. The asset handles are right here. They just have a regular old usize identifier. And I also have typed and untyped handles. Untyped handles allow me to have a handle into the assets so that I don't have to worry about having a type parameter everywhere. It's kind of useful sometimes. And assets are world scope, like resources. Like I said, they're just indexes basically into this assets resource, which is added by default into the world via the asset plugin. As you can see, this is an example of a plugin that I can just add this to the world when I instantiate it. I'm building it, and it'll just add these resources, add the resource of the assets into app, and then I'll be able to access it from anywhere after that. So anytime I have access to the app or the world, be able to access that resource, access any asset that I want, mostly have to have it the right handle. So pretty handy, pretty useful. I've also rewritten the entire renderer again, and it's based on the concept of render graphs now, and render nodes, and kind of the flow of information and resources from one node in a render graph to the next. I have this render trait that allows implementers to do some rendering work to some renderer resource. And I also have this slot enumeration, which is inputs and outputs to these render jobs. I'm able to use these nodes in a graph. This is the start node. It just by default grabs the current frame of the main window that the renderer's main surface, which I would like to change this in the future and have it so I can render off screen. But for now, that's how it is. Especially when I get into doing shadows, I'm gonna have to add more render targets than just on the screen. When I get into doing HDR and stuff as well. And the render graph is using petgraph. Petgraph Rust create to have a stable directional graph between render nodes, and it just kind of walks the graph in order to render. Yeah, breadth first search that ensures that every dependency is accounted for before running the graph. I also have these special traits and plugins for managing GPU resources. So you can see I have render assets here. So I have a render asset that I'm able to insert as an actual asset into the assets, and the assets structure that I showed before in the Weaver asset crate. And then I'm able to map the extracted render assets from their handles in main handles to their render handles. This is why untyped handle comes in handy, because it's just generic over every single handle, every single asset that can ever exist. And then I'm able to have this extract render assets system. This is actually a system, but it's a generic system. So this is a new feature of the new version of Weaver, is so I can have generic systems that act like functions, but they can be generic over some type parameters. So I'm able to actually have a extract render asset system run that extracts the render assets for whatever asset type, render asset type I want it to, and I can add the plugin for that render asset type, and it'll just add these systems into the extract and pre-render stages running the app. So that's pretty cool. Like, for example, if I were to have a mesh that had this extract render asset logic, and then I would have a mesh plugin, and this mesh plugin would add the extract render asset plugin to the app, which in turn would add these extract render asset for mesh for the system. So, and so on and so forth with things like materials and textures. Such cameras have, I believe, render components. Yes, there are render components that have some kind of GPU allocated resources associated with them. So then we will to have the camera plugin that adds a render component plugin, component bind group plugin, because it also has a bind group that it needs to take care of. So pretty cool, pretty cool. I also have GPU versions of resources and assets. Like I said, I have components, GPU versions of components, GPU versions of resources, GPU versions of assets. So, resource render component up here, basically all just copy and paste, but for the 3 different types of traits for assets, components, and resources. So, as for what else I have, I'm gonna reform this section. I also have implementation of my PBR renderer, physical based rendering. I also have a kind of baby event listener portion of the renderer, or a portion of the game engine now, that I actually haven't tested yet. I haven't used this yet, but it kind of exists for now. I've re-added eGUI implementation or eGUI integration. I've got Winit plugin now for managing a window instead of having to let app managed by the app directly. I also have a little simple collection implementation with procedural macros for all that and stuff as per usual. Nothing too fancy here. It's just the ability to represent the code structure itself at runtime with code. So, and manipulate it and do stuff with it. Like, this is all metadata associated with a struct that's deriving reflect. So things like its type ID, type name, all static stuff, fields, code info. I think that about covers it. A nice quickie today. Really don't have much more to show other than just the gory implementation details of what I've been working on. As for what's next, I want to keep re-implementing the features of the renderer, things like shadows and HDR rendering and boxes and image-based lighting and stuff like that, stuff that the old renderer had. And eventually I would like to get started on adding scripting support, probably with Lua. So, thank you all very much for watching, and once again, thank you all for 3,000 subscribers. Really means the world to me that I've received so much support on this channel. If you like what I'm doing, if you like one of my videos and want to see more, please make sure to subscribe and hit the bell to get notifications. If you have any questions or comments about what I'm doing, please feel free to leave a comment. And I'll see you next time. Thank you all very much. Peace out.